Thank you for joining us today. I'm David Rizzo, the Vice President of Engineering for Compuware. Joining me today is Matt Kramer, Scrum Master, and Mike Machnick, Software Developer. In this video today, we're going to show you a comparison of the 3270 interface versus the modern Topaz interface and how to debug a COBOL application. You'll be seeing us go through an actual COBOL application debugging session, debugging a Strobe bug that was found in COBOL code, and we will go through and show how we use the Compuware products within Topaz, including Expediter, Strobe, Hyperstation, and also our integrations with some of the other tools such as Jenkins and Sonar. With that, I will turn it over to Mike.
So an issue is reported in JIRA, and the first step we want to take is recreating the issue. So I'm going to go to SDSF, and I've already recreated the issue. And viewing the job here, the job ab-ended with a 322, which tells me that the job is running longer than expected. So now I want to use Strobe to pinpoint exactly where the problem is occurring within this job. So I'm going to open another screen and go to the Strobe menu. And within Strobe, you have Add Active and Add Queued. And I want to do an Add Queued to create a measurement. And this is the job name that we saw on the previous screen. And I'll just hit Enter here, and it will tell me that the queued measurement was created. And if I PF3 and go to the Strobe status screen, this is where where Strobe shows me the status of any measurements I have currently requested. I've already run the measurement for this job, so if I type a P to create a profile, and I want to process in the foreground, so I type F and hit Enter, and this brings up a Strobe profile. And within a profile are various reports. The report that I'm interested in here is the program section usage summary. So I want to find the tag #PSU, which takes me to that specific report. And within the report, I can see that Strobe 10 is using up 99.97% of CPU time for this job. So I know that the problem exists in Strobe 10. And that is the old green screen way of pinpointing a problem with Strobe. And now we're going to go through the new way.
So when we're working in Topaz and using iStrobe, you can see here we have the JES Explorer, which gives me the same view of all of my jobs as SDSF does. So here we can see highlighted the 322 ab-end job that we used to recreate the issue. We can see without going into further detail and having to dig in the actual job output what the result of the job was, the class it was run in, and just general information. So we know that, as Mike had said, we have a 322, which tells us that this job ran out of CPU time and something was probably running longer than it should have and taking up too much time. So what we want to do is run a Strobe request on it. So with Topaz, all we need to do is click on the job and then over here click the Strobe request button. This will bring up it will pull in all the job information and bring up a screen to submit the add queued request. So here all we need to do is give it the host ID that we want to use and click OK, and that will create the request. Then all we need to do is go down here, right click, and resubmit the job. And what will happen then is iStrobe will automatically create a profile for this, and it will go ahead and send us an email when the profile is ready for me to view. So if we go into my email, we can see here we were sent an email from iStrobe, and we're going to go ahead and click the Strobe Advisor link, which will take us into the web version of Strobe. And what the Strobe Advisor does is it makes recommendations on pieces of the program or application that has room to be improved. And here we can see that Strobe 10, like Mike saw, is eating up almost 100% of the CPU. Here, though, we can also see that we're given the actual line of code that is using the most CPU time as well, so we have a little bit more information to go off of. We also have access to the same reports that you saw in the report Mike looked at. So we can go ahead and look at the program CPU usage and see the same information that he saw. So we have all the same information, only in a little bit more user-friendly format. So the next thing we want to do is, now that we've identified Strobe 10 as the potential problem, we want to go ahead and check out the code and get an environment set up for us to make our changes and do our testing in. And to do that, we will switch back to Mike to show the old way.
So now that we know where the problem is, we need to start testing the code and make changes. So I'm going to use ISPW to obtain a copy of the source code in which I will then make changes. So I'm going to the ISPW menu, and then I'm typing P for containers. And so I've already created a container for this particular issue, and I'm going to select that container. And once I'm within the container, I want to type A to add a task, and this brings up a screen that asks me specifically what I want to add. So I have to type the source type, which is COBOL, and the module, which is Strobe 10, and I hit enter, PF3, and then it takes me back to the container screen, and I've already added Strobe 10. But from this point, I would type C to check it out, and then AG, which brings up a panel to generate the source, and this will create the load module and the object. And I just hit enter here, and ISPW creates all that for me. So now we are going to show the newer way for accessing ISPW.
So we left off in the JES Explorer, and now that we know the problem is somewhere in Strobe 10, we want to do the same thing that you saw Mike do and create an environment for us to do our changes in. So I'm going to switch over to the ISPW perspective by clicking ISPW in the top right corner here. And here we can see the repository view, which we can look through elements and see the members that are available or in different parts of the life cycle. And then here we can see the list of assignments. And what an assignment or a container basically is you can think of it like a unit of work. So we open up an assignment for every enhancement that we work on, or for every customer issue that we work on. So that way all of the changes relating to that are contained in one location, So they're all in one spot and everyone knows where to find them at any given time. So you can see we've opened one already for high CPU execution in the Strobe reporter. So I'm going to double click that to open it. And the first thing that we're going to want to do is add a task for Strobe 10. And we'll do that by clicking the Add Task button here. And we will type in Strobe 10 and let it know that it is a COBOL module. And then hit OK to add it. And the next thing we'll need to do is check it out. So we would right click and we would select checkout. And to get a better idea of what that would do, we can take a look at the life cycle. So this is the life cycle that we use at Compuware. It's relatively simple, and you can see here when I highlight the Strobe 10 member, it tells you that it's currently at the Dev 2 level. And basically what you do when you do a checkout is it's making a copy of the member, in this case Strobe 10, from the production level down to whatever development level you've specified.
Matt, you have indicated that this is the setup that is available at Compuware. How many legs are there that can have a maximum at different sites?
Yeah, so the life cycle is completely customizable. You can have as many development levels as you might need, or as many levels in between development and production. At Compuware, we try and keep it as simple as possible, so we've chosen to go with something a little bit simpler. But you can add in as many levels as you need. If you need additional levels for testing, maybe you have several different test sites that your changes need to be run through, or maybe you have different approval processes that require different steps in the life cycle. So ISPW can accommodate all of that, and it can be customized to kind of however you need to do your work. And that, like I said, we try and keep it a little bit simpler with our own life cycle, so that way there's as few steps as possible between a developer making their change and a developer packaging those changes and testing them and getting them out to the customer. So that's why we have the model that you see here. We have the 2 development levels here for people to make changes in. There are 2 of them because sometimes people need to work on concurrent changes to a particular module. You see the hold 1 level, that's where we do our integration testing and our regression testing from. So when someone pushes up their changes to hold 1, that's where our regression gets run from, and you'll see a little bit more about that later on. And then from then, once everything's tested and passed all of our tests, it gets pushed to PTFs, which is where we package and ship our PTFs from, and then to prod, where the production version of the source lives. So now that we've checked it out, the next thing we would want to do is do a generate. And that will compile the member. It will create the load library, or the load module, the listing, and everything we will need to do our testing and make our changes. So at this point, we're ready to go ahead and step a little bit further into trying to figure out what exactly is wrong with the Strobe 10 member. And to do that, we're going to pass back to Mike, who will show you the old way.
So as Matt mentioned, we're at the point where we want to debug the program. So I'm going to type start and open another window, and we're going to use Expediter to debug Strobe 10. So I'm going to our Expediter menu, and we want to debug in batch. So option 3 and option 1. Here is where I will enter the JCL that I had shown earlier for recreating the problem, and I select it out of my personal data set, and Expediter will read the JCL and show the programs that are being executed. So before we start the session, we want to type setup and option 1 for load lives, and here we want to validate that we're pointing at the ISPW libraries in which we generated the module. And then I want to type run, and then I for interactive testing, and this will submit the job. And so now Expediter has gained control. And so I can see that the program being executed is not Strobe 10. So I want to find Strobe 10 to see where Strobe 10 is getting called. And I can see that that call is right here. So I'm going to set a breakpoint. And then I'm going to type intercept Strobe 10, which will cause Expediter to gain control when Strobe 10 is called. Then I'm going to hit PF12, which brings me right up to the call, and then I hit PF9 and PF9, and so now I can see that I am in the Strobe 10 module, and I can type the command AA-snap, which will bring up an Abnade report, which allows me to validate my testing environment. So if I page down in this report, I can see that the main program is coming from the ISPW libraries that I generated in earlier. So now I just want to hit PF12 to let the program run. And I can see here that my session is clocking, which tells me that Expediter has run into the problem. So I right click and type or click attention, and here I have a list of commands I can enter. I want to type pause, which will pause execution for this job. And if I page up a little bit, I can see that there's a loop with a high count. And so this tells me the problem exists in this loop. And so this is where I likely need to make my change. So I want to break out of the loop. So here on line 2988 is the end of the outside of the loop, so I want to type go to 2988, and then I just want to hit PF12 to run the program, and I know that if the program comes back with a return code 0, which it did, I know that specifically the loop that Expediter encountered is where the problem exists, and that's where I need to make my code changes.
So Mike, as you went through that, you did a lot of PF12, PF3s, and commands. How did you learn and know what commands to enter?
I learned that by reading various Expediter manuals and then having to be familiar with ISPF and lots of practice and training. So now we are going to show the new way for debugging.
So we left off having just generated the Strobe 10 module. So now that we want to go into Expediter so that we can step through the program and figure out what's going on. So we're going to switch to the Expediter perspective by clicking on Expediter in the top right corner here. And here it's a little bit easier to start because I have several debug configurations already defined. Here you can see there's about 6 of them, and these can be imported and exported so that they can be shared among team members or with people outside the team as well. So that makes it a little bit easier. So if I'm debugging a part of Strobe for the first time, I can, instead of having to go through the whole setup process myself, I can just take advantage of a configuration that someone on my team has already defined. And so that's what I've done for this one. I've imported a configuration for someone who's already done debugging in the Strobe reporter. So to start that, all I need to do is click and start the debug session. Shortly here, what you'll see pop up are 2 different windows. One of them is going to be for runtime visualization, and the other will be for actually debugging with Expediter. So briefly here, we'll switch back. You can see this is the runtime visualization. Currently it is only showing the Strobe DT module, which is the main entry point to the reporter. But as we step through the program, we'll periodically take a look back at this because it will be building this diagram dynamically as we're debugging through the program. And this will help in getting a better picture of what the application, how the application is constructed, and how Strobe 10 fits in the application. So, I might, as someone who might be newer to working with the Strobe reporter, this gives me an opportunity to get not only an understanding of Strobe 10, but a higher level understanding of how all the pieces in the application fit together. And then here we see the debugging window, which will allow us to step through the program. Also here, you can see that there are already a couple of breakpoints defined. Those as well can be imported and exported and shared among members of the team. This can make it a little bit easier for, say, I run into an issue and I want to ask someone a question about a particular problem I ran into while debugging. Someone, they might be remote or not there at the time, so I can actually import or export my breakpoints as well. That way, later on, they can easily recreate the situation I did and get back to the point in the program that I encountered the issue. So what we'll do here is continue, and we see here this is where the call to Strobe 10 is being made. So we will continue one more time, and that will bring us into the Strobe 10 module. So we'll take a quick glance back here at the runtime visualization, and we can see there's a number of, this has been built out a lot more than the last time that we looked at it. So this is actively adding modules as we're debugging and stepping through the reporter. So already we can get a better understanding of what modules have been run through already to get us to Strobe 10. The other thing we're going to do at this point is, now that we're at the entry point of Strobe 10, we want to set up ourselves to have a unit test using total test. So we right click, and now with Topaz for total test we have 2 additional options here, and we're going to generate a unit test. So here we'll use an existing project, and we can use all of the defaults here for creating stubs as well. So we'll go ahead and hit OK. And what this will do now is, as we're debugging the program, Expediter, total test using Expediter will be capturing the information that's being passed into the Strobe 10 program and the information that's being generated as output. So that way, when we want to rerun through a test later, total test knows the correct values it should be expecting out of all the different fields. So for now, we've created the project and it's being generated, and we'll go ahead and take a look back at that later when we go through testing. For now, though, we'll go ahead and continue with our debugging here. So when we were in iStrobe, we were actually given the line of code that was encountering the error. So what we can do here is we can actually just search for that line of code. And here we see the same move statement that we saw in the Strobe Advisor report. So we're going to set a couple of breakpoints here in this area by right-clicking and toggling a breakpoint on. And then we are going to continue to run into so that we can run into these breakpoints. And now we can, looking at the variables on the side here, and looking at the code here, we can see the same thing that Mike was seeing when he was debugging. It seems that the max params value is set to a value that's too high and is causing it to get stuck in this loop for far longer than it should. So for now, we're going to just decrease that and see if that will get us through this loop and successfully exit the program. And we will continue along for that. And we can also see, if we switch back now, that more pieces have been added to the runtime visualization. Now we can see where Strobe 10 fits in and the other file inputs to help us learn more about the application. So the next thing we're going to want to do is, now that we've identified what the problem is in Strobe 10, we want to actually make that change and test out those changes to make sure that everything is working correctly. And to do that, we're going to first step back to Mike, who's going to take us through the old way that we did that.
And Matt, when you look at those features that you used with Expediter and the Runtime Visualizer and Topaz for Total Test within Topaz, does that require that you're using ISPW to be able to take advantage of any of those features when you're doing debugging and testing?
No, none of those features are directly related to ISPW. Total Test makes use of Expediter to collect all of the data it needs, as well as Runtime Visualizer. So both of those products make use of Expediter to do what they need to do. They do not require ISPW.
So as Matt had mentioned, it's time to make the code change. So we are going to use ISPW to make the change and promote the change. So hitting PF9 and flipping back to my container in ISPW. What I want to do now is select Strobe 10, which takes me to the source, and I want to find the location where we were setting a value to high, and I want to make this just a bit smaller, and I'll PF3 here, and so once the change is made, I'll type P, which will promote Strobe 10 to the next ISPW level, which is designated for our unit testing here at Compuware. And then from this point forward, I will have to send an email to someone in QA to create tests for this specific problem in HyperStation, and once they get to it, the tests are then added to a HyperStation ATV that gets run on a nightly or weekly basis, and then the results of those tests are manually checked in SDSF. the day after they are run. And so Matt has a more automated way for how we do things now for testing.
Okay, so we left off having just finished our debugging session. So now that we actually want to make our change, we're going to click in the top right corner to switch back to the ISPW perspective. And here we will double click on the Strobe 10 member to open it up. And here we can do all of our editing with a modern editor that is a little bit easier to use than the ISPF editor. And we just saw Mike make these changes, so we don't need to go through them again. And then we would save, and we would then want to generate this member with our changes. So as we saw before, we will right click and we want to generate it. That way we will have a load module that will have all of our changes that we can test from in ISPW. And the first thing we're going to want to use to test is at the development level, we'll want to do our unit test, which we created with total test. And we're going to switch over to the Host Explorer perspective by clicking in the top right here, and we can see what was created for total test. Here on the side, under Projects Explorer, instead of under Host Explorer, we can see the project that was created by total test. And we can see all of the data and structures that were created, but we want to go ahead and open up the scenario to be able to look at it and rerun it. So here we can see the input that was captured by Expediter. And here we can see some of the parameters that are going into the Strobe 10 program. There's an array of program IDs here that's 50 elements long, and we can see some of the first ones here. So here we can see all of the information that's going in. You can actually make changes to this information as well. So if you wanted to see what would happen if instead of these program IDs, it got this different set, or if you wanted to change any of the inputs to kind of test what would happen or how your program would respond, you can do all of that using total test. So we just want to use the captured data though, because we want to make sure nothing's changed and that all of the data is consistent with how it worked beforehand. And to do this, we would just click here to rerun the test scenario, and that would allow us to validate that the input is, or the output that's being received is still consistent, and that our change hasn't adversely affected the module. So then we want to switch back to ISPW, and now that we've done our unit testing and we've made our change, if we look at the life cycle, we want to do a promote, and that will push it up to the hold 1, which is where we do our regression testing from. So to do that, I would right click on Strobe 10 and click on promote. And this will present you with some options, but you can just use the default most of the time. So I'll go ahead and click OK. And that will promote the Strobe 10 member up to hold 1. And when it gets there, it's automatically generated as well. So it will have the load module and the listing and all of that stuff will be available at the hold 1 level and ready for the regression tests to pick it up. Typically, our regression tests get run at night with Jenkins. We have it set up so that when code is promoted into hold 1, Jenkins is notified, and that's how it knows. It checks at night whether anything's changed, and tests would be run, and in the morning you can come in, check the results of the testing, make sure everything's okay. But in this case, since we're working on a customer issue, we might want to run the tests ahead of time so that we can get the
fix out more quickly and be confident that our changes are correct. And you can see here too, once the promotion is complete, it actually moves up in the life cycle diagram as well. So now we can see that our version that we have in our assignment is at the hold level instead of before where we saw it was at the dev level. So to run that regression, we're going to go and switch over to Jenkins. So here is our Jenkins dashboard, and we are interested in rerunning a test for Strobe. So we're going to go ahead and click on the Strobe tests. And then we know that we want to rerun the test for the Strobe reporter. So we will click on that project. And now to rerun it, all we have to do is click Build Now. That schedules the test, and you can see that it adds it to the build history. But to see a little bit more about what's actually happening, we'll take a look at how this test is configured. Here we can see some basic information in the description about what the test is covering, what operations it's testing and what it's doing. So if you're not familiar with the tests, you can kind of see what each one covers. And if we scroll down a little bit here, we can see the LPAR where the tests are being submitted to, and we can actually see a job that's being submitted that will run all of the hyperstation scripts to test the interface to the Strobe reporter. And so this submits all of our hyperstation, and once that is complete, at the bottom you can see it's set up to do email notifications to all of the people on the team. That way, once the build's finished, everyone on the team or anyone else who would need to know can be notified of the results of the test and be immediately aware of whether there were any issues, and then they can appropriately respond to investigating those issues and making sure if anything's wrong, they can figure out what's going on there. Additionally, as part of our regression process, a sonar cube report is created. So I'm going to switch tabs here and take a look at the sonar cube report for the Strobe reporter. So here, what sonar cube does is it gives you information about code quality, and there's various pieces of information here like code duplication, technical debt, and some of you might be alarmed to see it says that we have 1,800 bugs, but Sonar has a little bit different of a definition of what a bug is than what you might be thinking. It bases all of its reports here off of coding rules that are defined for your site. So these can be rules that are defined as like a language, as far as not using particular options, or how you want your code structured, to being just site standards of how you want things documented. So you can have Sonar report on those things. And if we take a look at what some of these bugs are, we can actually see that a lot of these are that at our site we've chosen to avoid using the corresponding option in our COBOL code. So a number of the issues reported are related to that. So these aren't actually bugs in the software, they're just improvements that we want to make that are currently not taken care of. So as a developer, the way that I want to use this information is when I make a change to a module, in this case Strobe 10, I want to go to the Strobe, the Sonar report for Strobe 10, and I want to make sure that I have not added any additional bugs or code smells or vulnerabilities, and so that I know the code I added is of good quality. And I also want to see, while I'm making changes there, are there any additional problems that I can address in that module while I'm there? That way, over time, we can slowly, bit by bit, address the known quality issues in our software. This is also makes it very easy because you can click on any one of these and it will actually bring you directly to the line of code that the issue is at and show you the information about it. So you can very easily see the context in which these problems are in the code. So at this point, I can feel pretty confident about my change because it's gone through our regression testing, it's gone through our my unit testing, and it's passed our quality standards as reported by Sonar. So I can feel very confident at this point as a developer that the changes I'm making are going to fix the problem and that they're going to be of high quality. So the only thing left for me to do is go ahead and build the fix and send it out to the customer.
Okay, thank you, Matt and Mike. That was very helpful. And Matt and Mike have both been with Compuware just over 4 years and learned how to do the old way and the new way, because when they started we were doing the old way and now we have all the new tools that we're using. And they learned both, so they were able to show that. So during the presentation, you've seen at the bottom of this slide, you see the traditional Compuware products that you probably and hopefully are very familiar with the fault management tools, Abendade, then with the data management tools and FileAid, testing, HyperStation, source code management, BRISPW, Strobe, and Expediter for debugging. So hopefully you've used many of those as traditional tools with the 3270 interfaces and are familiar with them. And then we added on that the Topaz Workbench, which gives you the modern IDE and the modern interfaces to be able to use things such as the right click and getting menu options and buttons on the screen to see all those things that are available without having to read manuals and learn all the different options, remembering which PF keys to use and what commands you need to use. And then building up upon that was some of the additional features that are available, such as the Topaz for Enterprise Data, which allows you to manage data. You didn't see a lot of that, but that's traditional data management and some extensions to what we do. Topaz for program analysis, which is a feature set that's available that does program analysis. You saw the runtime visualizer running alongside an Expediter session, so you can visualize a running program which is done off of the load modules, and there are additional features that can be done, static analysis of source and different things like that with program analysis. And then you also saw Topaz for Total Test, which is a newly introduced product from Compuware that allows you to automatically create unit test cases for programs as you're going through a debugging session, so that you can continue to build your test case library and create unit tests as you change code, so you can feel confident as you move forward that you've tested the code you've changed, and in the future adding it to a regression suite, that you can continue to not impact the quality of the code that you have run. So that is the evolution from our green screen to Topaz and some of the new features and functionalities that are available to do development in the modern environment.